Morning. At this presentation on the new SDK 6, my name is Ewout Kramer. I'm head nerd CTO at Firely. But also since I think 2012, when we started this whole stuff, the main developer, I started out as the main developer on the .NET SDK. There's a lot of familiar faces here, so some of you know well. But I'm also delighted to see that my whole team is here today, because I'm definitely no longer the only maintainer, luckily, of the SDK. So I have Andre here, who works with me on the SDK, Cas, and Martin, and so the four of us are mostly maintaining. So if you've ever had a discussion on our GitHub repo, then it would have been with one of the four of us. And the main subject of today is SDK 6, and I think it's worth spending time on SDK 6 because not all major new releases are created equal, and I must say that SDK 6 is really a big change compared to 5. SDK 5 was more or less, oh, we've made a few breaking changes, so we'll have to increase the major version number, right? That's what you should do. But the amount of changes for 6 is much larger, so that is definitely really worth a new major version number. And so we actually, the amount of changes was so big that we had a theme this time around. I don't know if we're going to, label our next release again, but for this time around, our theme was POCO is king. And that was because for the past, for the last few years, we've had basically two stacks in the SDK. Either, and I think it's still the most popular part of the SDK, you work with the POCOs, the generated C# classes, for each of the resources in the FHIR standard. And those are steadily generated, right? They have properties for everything that's in the FHIR spec, and so on and so on. They use the .NET type system. We slam some metadata on them to be able to map them to FHIR, and so on. But for a long while, we also had iTyped element. And iTyped element was more of a dictionary-based thing, and so it could contain incorrect data, which is useful for things like Forge that sometimes need to deal with incorrect data. But crucially, it also had its own type system and metadata, and this was iTyped element was always the base for FHIR path and validation. So our FHIR path engine actually runs on iTyped element. Who of you is intimately using the iTyped element side of the yeah, so that's about 4 or 5 out of this group. And we always knew that, of course, the POCOs were the most popular part of the SDK, because that's what most people do. They start up a FHIR client, get some data, modify the POCOs, and boom, deserialize, serialize, and so on. But there was a growing number of disadvantages for us. We're maintaining 2 stacks, right? iTyped element, as I said, each of their own type system, equality operations, parsers, serializers. Hey, Gino, good of you to come. Another very important participant in the SDK stack is Gino here, because we are all using Gino's POCO generator. So all the generated code actually comes out of Gino's stuff. And a lot of the ideas in SDK 6 came from discussions we had with people like Gino, and I saw Brian. Yeah, right, exactly, hidden there. And we kept on adding more metadata to the type systems, and we're like, we already have reflections and POCOs, and we're doing everything over again for iTyped element. And most people just prefer working with POCOs, and they're faster too, right? They're very memory efficient. Access to the properties is way faster than dictionaries. But the disadvantage of using POCOs is that they're not good enough for validation and FHIR path. And that is because for validation you want to report locations, and POCOs just don't have locations. And if you're deep down a POCO tree and you want to know what is the father bundle entry, you can't get back to that, right? So that's why we always use iTyped element. That had all that, that moving forwards and backwards in the tree kind of stuff. So for those who are not intimately familiar with how this stuff I-typed element and POCOs works together internally, it's really interesting to know because it matters for performance. So let's start the stack with our XML and JSON data. I know there's RDF data too, but we don't even have parsers for it, I think. So basically, in SDK5, this is what happens if you parse. Whether you go to POCOs or work with I-typed element, there are two parsers called XML node and JSON node, and they turn this really nice conceptually XML and JSON stuff into an iSource node, which abstracts away from the actual format. iSource node has no typing information, so the next step is adding type metadata from our own type data system for typed element, and then we have I-typed element. And if you don't want to use POCOs, this is where the fun starts because, if you do work with POCOs, there is a hidden class, you never use it, but if you call toPOCO on an I-typed element, there's an internal class called the POCO builder that actually constructs a POCO from this I-typed element. And if you don't, then you go straight into the validation and the FHIR path stuff. Now, what you need to know is that if you enumerate the elements in an I-typed element, basically what you're doing is you're enumerating the elements in an iSource node, and what that does, if you're enumerating that, it's parsing the XML stuff. So every single time you walk through the tree in an I-typed element, you actually reparse the whole XML and JSON. Now we can say, we signal that because I-typed element, if you do children, if you go deeper in the tree, it's actually an I-enumerable. So you know it can be slow, but a lot of people forget about that. They enumerate again and again and again, and this time it meant parsing again and again. And all this whole stack is also in memory all the time because it needs to be able to do that. So what we did with the validator is we read the whole I-typed element into a DOM tree, so we don't have to parse and reparse it again. Add parent information, and then we validate. So this is pretty costly, having all this stuff in memory over and over again. Well, we already had POCOs. So guess what we wanted to do in, and so what we did already in SDK5 was saying, okay, so what if I don't want this stack? So we started to work in SDK5 on some like secondary stack, and we used like the new system text JSON stuff to have a new parser infrastructure that directly went to POCOs. Now, to participate in validation, these POCOs, of course, needed to implement I-typed element, so we created a wrapper called the POCO element node that actually implements I-typed element, and bum. So basically what happened, if you did not use the new parsers, is that you parse stuff to I-typed element, you build POCOs out of it, and then when you wanted to validate that, we had to wrap them again with I-typed element and then validate it. This is not the best thing to do for if POCOs are the most important thing in your stack, if 90% of your users are using POCOs. So that's why SDK 6, we said, you know what, POCO is king. Let's see if we can clean up this whole stack and make this way more efficient for if you're using POCOs. Hell, let's try to only have to use POCOs. So in SDK 6, we went further where we started in 5. So we still have this, of course, untouched I-typed element stack. So for those using I-typed element, remain calm. It's all there. It's all there unchanged. There is still a POCO builder to get you from one world to the other world, to the blue POCO world, so to say. But instead of having the whole validator on this side, we moved everything over to the POCO side. So you parse XML and JSON with the fastest parsers we could write, the POCO XML parser and the POCO JSON parser. So any one of you who still finds ways, I'm inviting you to increase the speed here. We're still trying to get this as speedy as we can, but now we get the POCOs directly. And yes, now if you want to go back to your old world, you can. And what we did is we still wrapped POCOs with something called the POCO node. That implements I-typed element if you want to go back to the I-typed element world, but otherwise we're going straight into the validator. And so, since POCOs still don't have a sense of what's my parent and what's my location, this little POCO node thing that we have around it, that is actually what's keeping track of the parent. So as you move down the POCO tree, we build in memory still a parent-child relationship there, but it's all there. So if you re-enumerate the children, there's nothing to re-enumerate. Everything's already in memory. I don't need this element node that reads a whole I-typed element tree into memory. Everything is already based on the POCO. So let's focus a little bit on this magic piece that's called the POCO node. So obviously the POCO node refers back to a POCO. So this is the very comfortable side of this new architecture, is that wherever we are dealing in FHIR or the validator or wherever we need to navigate through the POCO tree, we always have access to our own familiar POCO. So the POCO really definitely is king here. And POCO node for us still implements I-typed element, I-source node, and I-enumerable. We did that because we realized that you might have, if you've been using I-typed element before, you might have tons of functions and stuff that has I-typed element in function signatures. You might have like I-typed element, everything. So we thought that if we made POCO node still implement I-typed element, you can step-by-step switch from I-typed element to POCOs in parts of your software and still treat this new POCO construct as an I-typed element. So you could marry the two. You could, for a long while, use both in parallel and slowly move over, if you wanted to, all the way over to POCOs. And POCO node has children, so it can list the children, and while it's traversing deeper into the tree, it keeps a pointer back to the parent. So this means that in FHIR we can do stuff like $resource or $context and so on, and move up in the tree, and also provide error locations while validating. But why didn't we do this at first? Because POCOs are statically generated classes. So what if you encounter data, or what if you want to deal with, well, incorrect data? It doesn't necessarily need to be incorrect, but what if you have a newer version or an older version of FHIR, and you're trying to parse that, and you're working with one version, and you'd say, oh, well, I want to parse different version of FHIR, or if you're a tool like Forge, you simply need to be able to parse incorrect data. We all want to be able to parse incorrect data. This flexibility existed in the I-typed element, but if POCO was really king, we needed to port those whole concepts over to the POCO world. And this is where we had tons of discussions before at workgroup meetings with Gino and Brian, and we said, what if, but this was all fantasy back then, what if, where would we find, where would we put a place for all this incorrect stuff? And what if we added to any resource, so base, we'd add a dictionary of string objects. So if you're setting data on your POCO while parsing that is correct, you just set it straight on the POCO. But if you encounter something that's incorrect, add it to the dictionary. And I'm not exaggerating if I think that we've been thinking about this for about 2 years on how to actually make this work and make this work performantly. So the situation in 6.0 will be that you'll have your trusty POCOs with the normal properties, but you'll have a iDictionary-based interface on the resource. And if you access the POCO with that interface, you can both set the normal properties and you can add totally unknown elements and fields. That's on the domain resource side. On the primitive type side, we had this magic object value that could contain anything. So the primitives are like booleans and so forth, and codes, and so on, integers. And we already had the feature there that if something was spelled incorrectly, so a wrongly spelled date, true, misspelled true, a code that didn't exist in any num, we just stuck the stuff in a primitive element called JSON, or object value actually. So a FHIR boolean would have a value bool, but also an object value that was of type object. You could put any stuff in it. That still remains, but we've renamed it to JSON value because it basically will always contain the stuff that you find directly in the JSON, whether the data was correct or not while parsing it. So how do we use that in practice? I have a patient here. And when I construct a list of human names, so let's say we try to set patient.name. Now, patient.name is of type list human name. So when I actually create a list of human name, and I use the patient's dictionary interface to set it, then this setter, this implementation of the dictionary interface will say, oh, that's actually a known property. It's correctly typed. So it will immediately set the POCO property itself. So patient.name should equal this one. And conversely, if you set patient.name property and you ask for it by its interface, by its dictionary interface, you'll just get it, right? So that works. But setting it to something incorrect, so let's say we set name to a list of FHIR booleans instead of a list of human names, the property will throw. If you try to get the property. So the POCO will actually use its internal dictionary that I showed you to record patient.name in that dictionary, but it will clear the name property, and actually when you want to access the name property, it will throw. We did this instead of returning null, because it means that you can never make the mistake of reading incorrect data with an incorrect name, so to say, and then trying to get the name, you just get a null and you conclude there was no name in the resource. No, there's no way you can get this wrong. If data got lost, if there's incorrect data, the property will throw. But also means now, and that's the fun of course, if I use a property that doesn't exist, so let's say I'm actually parsing stuff in R4 and the data I'm getting in is R5, and there's a new element, we will capture that in this new overflow dictionary. So when I'm dealing here, when I'm setting it on the interface, it will be retained. If I say that to null, it will be erased. And if you use enumerate elements, and that's of course what the validator and the serializers do, they use this dictionary interface, enumerate elements to get all the elements. It will always list both the properties of the POCO and the stuff coming out of that dictionary. Is that clear so far? So that proved. Now this had the consequence that the next change we had to make is that it shifted the balance of what was possible in the model. So let me take you back to parsing. Imagine that you're parsing a resource in 5, and I encounter a mistake while parsing that I cannot maintain the data in the POCO because there's this element that I don't know about. The only thing we could do in 5 was let the parser create an error and saying, like, I have this unknown element. I really can't store it in the model. I'm losing data here. So beware, you lost data here. Now with this new 6 model, this is no longer a real error for the parser anymore because I can stick it somewhere. There is no data loss. So our whole concept of what was a fatal error, what was data loss in the parser, that changed. Because already in 5.0, you could say, okay, dear parser, just continue on parsing whether you encounter errors or not. Try to put as much stuff in the model as you can, and then warn me whether I had data loss or not, because that's the only thing I'm interested about. And this shifted because in 6, we basically can store almost anything. So the responsibilities of what is a parse error, what is a validation error, and what is a profile parsing error has shifted because of this design decision. And I don't think we fully realized this when we started with 6.0. So that means that our parsers, the parser errors, have moved sometimes from being parser errors to being model validation errors, because we can simply parse it and put it in the overflow. And only when we call model validation, then the error is reported. So in SDK 5, almost all syntax errors were data loss, unrecoverable. We caught some terminology errors while parsing. Of course, we found most of the JSON syntax errors, but all the semantic errors, unknown elements, lists where we didn't expect lists, single elements where we expected lists, we didn't know what to do about those. In 6, we have way more flexibility. So basically, the parsers in SDK 6, they detect the syntax errors. Because anything else we can put in the model, which means that now the model catches all semantic errors for us because they're no longer, it's no longer necessary to catch them here. This has the advantage that if you're not using a parser to construct an object, but you're constructing it manually, what also happens is that much more of the validations are actually on the model side. So if you call validate on the model, you get a richer experience in validation. And finally, of course, just to point out that this model validation, so calling validate on a POCO, is never as complete as profile validation because there is still slicing, invariance, terminology, and all that stuff is not there. So you still need to run the profile validator. But even though some of this responsibility shifted from parsing to model validation, what does happen is that while parsing, we are still calling model validation for you. So in the end, if you call the parser, if you invoke the parser on XML or JSON, you will get both the syntax errors and the semantic errors. And if you want pure speed, you don't care, and there's ostrich mode, we call that, of the parsers, we switch off all this model validation. And so the only thing that bothers us now is just, are there any really weird syntax errors? No, okay, just push it in the model and you're done. And this is the fastest parsing you can have, of course, because we don't care about anything anymore. You could always call validation later. It gives a tremendous amount of flexibility. For example, we never realized that this would allow us to parse structure definitions for R5 or R6 with our R4 parsers, or actually write a validation for all these versions, and then just depend on overflow to read the specific R5 stuff. So we no longer need to keep multiple code bases here. So this means that the validation, the model validation is now the core matter, and it's both called by the parser and you can call it yourself. So if I create an incorrect patient in memory and I call validate, you'll get exactly, so see if you go validate, you get an array of errors back. You'll exactly get the same thing as whether I'm parsing this, putting the parser in strict mode. See, we added a few static predefined parsers, and in strict mode, deserialize it, and the errors you would get would be exactly the same as those ones. Except, of course, if there would have been syntax errors here, obviously. But we have totally aligned in-memory validation and validation from the parsers. And as a detail, this is done by something called an POCO validator. So we only have one implementation, so we'll see whether it's actually useful for us to abstract this away. But we have included the FHIR attribute validator, and that is the validator that takes all the metadata that is in the POCO and uses that for validation. And so that is both called if you call patient.validate and if you parse it. But you could potentially write your own implementation with your own business rules there if you wanted to, so that it gives even more flexibility. So all the parsers have a setting in their configuration where you can plug in your own POCO validator, and that will be invoked while parsing down the tree. Now, it's important to realize that the parsers will just, and this is already true since 5, the parsers will no longer stop on the first error, right? They will always continue and put stuff in the POCOs, as I already said. And the only reason why you would get a deserialization error is whether the errors that are reported while parsing are considered badly enough for you to be able to signal. So if you configure a parser in ostrich mode, we basically say any errors are allowed. So you go on, and if we get me the list of errors, and then say, yeah, actually we don't care, right? Any errors is fine. Strict is any error is going to give you validation errors, and we have like some shades of gray in between. So errors that are not giving me data loss are okay, that's recoverable. So that's a very useful pre-configured serialization here. Any errors that are caused by backwards incompatible changes are okay, so you could use this one if you want to make sure that you can read newer stuff. And we have one that's configured to only protest about syntax errors, but you could configure those yourself. So when we had all that stuff in place, it was time for cleanup. After 12 years of having like in the very original version, say 1.0 or maybe even 0.9 of the parsers, I had handwritten parsers. Is that correct? Actually, no, we had the Java stack pre-generate parsers for C#. That was a hard time maintaining all that stuff. And back then, those parsers were called FHIR XML parser. And FHIR XML serializer. That's just basically how we are called. And we were not completely consistent whether something was a parser or a deserializer, so we messed around a little bit. And then, so this stuff has been there, XML serializer and XML parser were the original SDK 1, so to say, thingies that have been there for a long time. But then when we introduced I-typed element parsing, we added the iSource node, XML node, and JSON node parsers. And then when I wrote the system text JSON-based direct POCO parsers in SDK 5, we added things like base FHIR XML POCO serializer, base FHIR XML POCO deserializer. You can see that we're already looking for what names do we still have? Won't this get confusing? So basically, for parsing XML, we had the old FHIR XML parsers, we had XML node, and we had FHIR XML POCO deserializer. It was not a happy situation, but that is the situation in 5. But for the FHIR XML parser was really a classic interface on top of the I-typed element stuff. So if you had code that used FHIR XML parser, you were really using the, as I can now say, a little bit slower I-typed element stuff internally. For 6.0, we wanted to clean all of this up. So what we've done in 6.0 is say, you know what? FHIR XML serializer is actually a good name. So let's build this whole new stack. Let's rip out all the internals of the FHIR XML serializer that in 5 actually used I-typed element and make sure it uses the new serializer and deserializer stack. And on the other side, we say, you know what, FHIR XML parser wasn't maybe the best name. Let's call this FHIR XML deserializer. So we have FHIR XML deserializer, FHIR XML serializer. And we kept all the other stuff in place, but we obsoleted them. So this all still exists. This all still parses I-typed element. But now FHIR XML parser will do, you know, the right thing. We actually kept the old classic interface as extension methods on the new FHIR XML deserializer. So in theory, all your stuff should compile, right? But we're in the phase where we're trying this out. We're trying this now in our own products and see what kind of compilation errors are we going to get if we just plug in 6.0 and press compile. But we've really tried by constructing the subclasses to make this as painless as possible. But if you want to go straight for what is 6.0, the FHIR XML deserializer and the FHIR XML serializer are the new kings. They contain the fastest code. The rest of it is there for backwards compatibility. Now, as you probably know, all of the parsers and serializers and most of the stuff are metadata driven. So the POCOs have metadata on them. That's already since version 1.0. And all the metadata is stored in something called a model inspector. That's just a big cache of reflection data. You could reflect it, you know, it's just normal .NET reflection, but the reflection used to be slow. It got way faster over the newer versions of .NET, but the model inspector is basically a cache of reflection data. And so the model inspector imports the .NET types, reflects all the metadata, represents all the individual POCO classes as class mappings, all the individual properties as property mappings, and so you can look that up. And it does actually so for a single version of FHIR. There's this real complication that we have a shared code base that is used across different versions of FHIR. That is in the common library and the core libraries. And so sometimes the reflection metadata exists for 3, 4, and 5 independently. And Model Inspector knows about that and keeps those versions separate. Now, we did a very subtle change in 6.0, and that is that in class mapping, the properties are now an I collection, so they're mutable. That's an important change. And I invite you to think a second on why we would have done that, because it means that you can add your own properties. And that allows you to, if you are expecting new properties, right? So you're going to parse something new, or you're going to parse something that you know has, like, for example, you want to have one code base, and you want to parse 5, or actually we more think about 6 here. We're looking ahead at FHIR R6, where I think we will be seeing multiple iterations of FHIR R6 adding new elements, and you want to support all of them. And so what you can do in the future is say, well, I want to support these extra elements. You know what? I'm going to add those to those class mappings because they know they're coming in. So they're no longer unknown properties anymore. They become properties that don't fit in your POCO, but are known. So that's a new feature. So I'll show you what that means. Say we have a patient here, and it has the usual active, but it also has 3 new elements called patient location. Looks like a string, but it might be a URI. We have remark string, so this is probably a choice type, but yeah, no, we can't really know. And we have a list with a single value, and in XML you can't really see the difference. So when we use the new parsers, then obviously active is true, you know, that's nothing changed. But if we access those new things, well, and if we access active by its dictionary interface, it will of course also be a FHIR Boolean. But if we ask for these new things, then obviously patient location is a string, nu.nl. Remark string is an element called remark string of type FHIR string. And the list, well, we can't see that it's a list, so the parser doesn't know anything about it, won't complain about it either if you don't want it to, and will store just this string in the dictionary. Now we're going to modify the class mappings. So we're going to say, you know what, this patient location is actually of type FHIR URI. And this is something you couldn't do in 5.0, is create your own new property mapping. That was a private constructor that only we did when we did reflection, and now you can construct your own custom property mappings. And you're going to say, you know what, remarks really is a choice type. So it's of data type, and the allowed types are FHIR string and markdown. Oh, so now we know this is a choice type. And new list is a list of FHIR strings. It's a list, okay? You know that? Okay, and that means that when we modify these property mappings, and now we parse this stuff again, the parser knows that this is no longer a FHIR string, but a FHIR URI, even though it still doesn't fit in the POCO, of course, and you can query it via the dictionary interface. But it will also know that the element is now called remarks, not remark string, because it's a choice, and new list becomes a list of FHIR string, even though in the XML you can't see it's a list. So this is a very fundamental capability now to be able to configure these class mappings. And of course, what we can't do in the 6.0 time frame, unless someone here in the community thinks this is a good idea, I want to help you out, is add another component that reads in a structure definition and adds custom property mappings for the stuff that is new, right? It's not a lot of work to make that work. We're almost there, but we're a real software company, and we said, you know what, we're going to ship 6. Our hands are itching to add this stuff, but we won't do this in this time frame. But it's not a breaking change. So in summary, POCOs now become a full replacement for I-typed element and I-structure definition summary. So we have a whole stack back, we moved our whole stack and all the logic back to POCOs. So there's tons of different other changes here where, because now everything is a POCO, we can finally define equality once and a lot of things we don't need to duplicate anymore. Overflow allows you to deserialize, as I already said, newer stuff into older stuff. So this might actually help you out having a single code base working with multiple versions. For example, our validation engine compiles a structure definition to some internal structure called an element schema, and we have SU3 version and a 4 version for it. We could now unify that code. One code base dealing with minor differences across versions. I still don't know how far we can take this, but I guess we can. For our FHIR R6, this means that we can have non-core resources without static generators. What I didn't show here is that we also have introduced a new resource type that is not in the FHIR spec, that is called dynamic resource. And dynamic resource is basically a POCO with no properties and just a dictionary. And so whenever we encounter a resource type that we don't know about, we'll use this dynamic resource. So we can even parse a bundle with a resource type that is totally unknown. It will appear in your bundle as a dynamic resource, and all its properties will be put on this dictionary. Really, I can hardly think of anything anymore that we can't capture. Well, in XML, there's a few things. Like if you put attributes on the contained element in XML, we have no idea where to put that. So that's one of the few things where we had no clue where to put the data. And so plant is a structure definition to class mapping thing, and we simply didn't have the time to do that. And basically, you know how that feels. Once you've started doing this kind of cleanup, you're like, let's continue this cleanup with other things that we always wanted to clean up. So we support .NET 8 and Net Standard 2.1, so we dropped support for Net Standard 2, which did mean we get support for default interface implementations and a few other niceties. We've added nullable annotations to the generic POCO. Now, this might be the biggest problem when you migrate to 6.0, because if, like us, you promote all the nullability warnings to errors in your code, this will give you errors, right? So all the POCOs are now neat, C#14, nullable annotated, blah, 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 everything we could. We updated everything. And so this will help you catch errors, but obviously also cause some compile errors. We cleaned up the POCO public service. So before we had two pre-generated methods called is equal and matches, I think, to do equality. But we made it much easier to create your own equality operators. And this is, for example, necessary for FHIR, which has a slightly different sense of what equality is. So we added a compare children function to base, in which you can pass a normal I-equality comparer from .NET, and you can, quickly write a pretty performant equality here, because compare children is actually generated for the POCOs, so it won't use any slow enumerations. It will just one by one go over all the properties and call your equality comparer, and then of course also include, if there is anything, the overflow dictionary. We removed all the sync functions from the FHIR client, finally, after 5 or 6 years. We think it's time that everyone is async now. We moved the data types, address, duration, human name, and ratio into base. So this means there's a bigger amount of shared data types that you can use across FHIR versions. We removed all obsolete methods and properties. So that might... And oh yeah, this one, I don't know why I didn't this in the first place, but code of T is now a subclass of code. It's a small change, but my good, this was painful. If you wanted to know whether something was coded, you had to check whether something implemented code of T, which isn't trivial in .NET. You had to, what is it? Is generic interface and blah 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 off? No, it's you just subclass of code. It's either a code of T and code, and they share obviously. The string value, so you can easily get the stuff. That's wonderful. Small things that actually matter. The current status of all of this. I think we're trying to release beta 1. Actually, did we press the button for beta 1 this week? I guess no, huh? No. DevDays. Yeah.
It's still this week.
Yeah. It's still this week, right? But we're all ready for beta 1. Andre last week run a performance test on the parsers, and we found that it was now almost comparable to 5. It's still a bit slower, and I know why, because we're still parsing against the dynamic interface, even if it's a known property. We know how to fix this, but it's marginal, so that's fine. We've tried ourselves using 6.0.0 in the FHIR engine and the validator, right? So all the validation tests are running on 6.0. I think we are currently trying to port Forge over to 6.0. Sorry? Forge works on 6.0. Okay, so we're trying one by one, shifting our own products and trying to get any kind of regression errors at this phase. And we're still going, what is still on our list for beta 2 is more performance tweaks, because we know we can do this faster. But at least we know we're not slower at this phase, which is pretty nice for a beta 1. As I said, well, of course, last on the list on the bottom, adaptive documentation. What's new? While we were discussing this, one of my colleagues said, can't we make a GitHub action that it checks our PRs and then actually detects whether we need to change our documentation. It's like, whoa, yeah, we should be able to do that with an AI. That would be cool, right? You need to change this example in your documentation if you change the interface. I really want that. Anyway, if you want to see where we are or you find bugs, and it's definitely possible at this moment, there must be regressions with these kind of changes. It can't be. If you go to the Firely NET SDK, in our issue list, we have the one SDK 6 issue on top that has everything we work on. So if you want to join it, please report any errors on our repo over there, and you can also see what we are doing. You can actually see that we are working on, if you click on projects here, that we're working on beta 2. And POCO shall live happily ever after, and I hope this gives us a nice and clean POCO-based thing. So I still want to improve the FHIR path engine, so it uses all this new POCO knowledge to speed all that stuff up. ID's enough, but for us this is a really big cleanup. We're really excited about this, and I hope you are as well. Questions? Brian?
Hello? Is this thing on?
Yeah, it is.
Why the switch from object value to JSON value and not raw value or something XML value?
Yeah, we did a lot of thinking about that one. Well, for one, we call it JSON value because the only values we allow in it now are the things used on the wire in JSON. Because JSON is the most used parser, so we were like, okay, we allow in JSON value a string, a Boolean, and I think it's a decimal, right? Yeah. Number. And so the parser, when it finds that in JSON, it can put it one-on-one into the object model, and it is in 99% of the cases. So that's the fastest path. And so the XML, it only has strings, so that actually has still to know, like, oh, but this is a Boolean, so I have to put the Boolean in, which means that the XML is slightly, still has to do the most work. But then again, the JSON was the faster one. And B, the reason we wanted to rename it, we could still have kept it object value, is that it really changed. Before, object value had to contain, or was supposed to contain, I think, a FHIR datetime, or not a FHIR datetime, a datetime offset, .NET datetime offset if it was an instance. It had to contain the enum if it was an enum, and maybe even a byte array if it was a base 64. And that changed. And if we would have kept it, call it object value, that would have been passed into your code without any compile errors. So what we did is we kept object value, for one. We slammed an obsolete on it and saying, listen, the domain of this property has changed, right? It will no longer contain .NET data offsets. So please change this to JSON value because, you know.
Where does the XML content go? Like the same sort of area where you would have otherwise seen it previously. So shouldn't the JSON content be going into that array of other stuff anyway? Like,
no. This is for primitives, right? So the array is used for So that's the separation we already had. We didn't change that. If you make a spelling mistake in a primitive, we don't put it into, we don't create a dynamic primitive with that stuff in and then add it to the collection. That is just too unexpected. We kept that the way we did it. And so for primitives, misspelled stuff is still in this old object value now called JSON value.
The XML parser dumps it into JSON.
Yeah.
That's what feels so bad about it. Like,
yeah, it
just feels wrong.
It feels wrong, but it's also... The XML world, the XML world is slowly floating away, and so this is also forward-looking. Like, okay, everyone's using JSON, so let's just move
a
that
code
way.
Comment on it, say
keep that
yes.
performance. It's not that it makes a big difference in performance or anything, but in this case, it is the JSON parser had to do slightly less work than the XML parser, and we felt that was a defendable choice. Yeah.
But in its JSON form, like in what it would look like in JSON.
Yeah. I saw another question. Yeah.
So you mentioned this dynamic resource type that you've added, which combined with the mapping rules you had mentioned in the previous slide, does that mean that there's now support for just full custom resources? Okay. I guess the follow. Are there? Yeah. Yeah. I was like, don't know how I feel about that, but okay. Is there only one dynamic resource, or if you wanted to make multiple mapping profiles for multiple different dynamic resources, is that something that could be done?
Yep. That's a really good question, because you caught us where we couldn't make that work in the 6.0 timeframe. So it would be really nice for us. I told you the only thing you can mutate at the moment is the properties for an existing resource. And there's currently not a way to say, you know what, I'm expecting a new resource type called animal. And if you encounter a new type animal, then create a dynamic resource for me and use this class mapping in the metadata and with these properties. So we can have custom properties at the moment, but not really pre-configured custom resources. We are going to do that, but it required actually quite a few more changes, because a lot of our code goes to the model inspector and looks it up by type. But for unknown resources, we can't look it up by type, and we can't also not look it up by dynamic type, because that's not unique enough. So we need to change still quite a bit of things to make that work. But that is, if you go to our 6.0 SDK issue list, this is high on that list, right? Yeah.
Hi, thank you. Could you explain how I could access a value of an extension? For example, if I would have a patient profile with a shoe size extension and I would want to access that.
Yeah, that still works like the way it did, because it simply means that on the resource, there is a normal extension property, which is an array, and in that extension array, just on the POCO side, there will be the extension with some URL. So you'll be filtering on that URL and finding your extension. So there's no change in there. But there might be an underlying question here, or at least the thing we're thinking about is, couldn't we, now we are here, while parsing, promote some of your most favorite extensions that you know you will encounter to like properties that are in the dictionary and so can be accessed straight from the dictionary. And specifically, that would be nice, and specifically all the cross-version extension stuff. Cross-versions I'm expecting cross-version extensions will become really important, because there will be a lot of cool stuff in R6, but you're stuck to 4 in your jurisdiction. So the cross-version extensions will allow you to use R6 features in R4 as extensions. And you'll see tons of extensions on R4 instances, and that will look ugly, and it will be, they have to be accessed just like I told you. Get to the extension array, filter on the cross extension, blah, 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 blah. Wouldn't it be possible to make a custom property mapping that says, look, this property is actually encoded as a cross-version extension? It's not a big step. We're very close to do that. And so then you would be able to just manipulate these as elements in your dictionary. And when serializing, we'll serialize them as cross-version extensions. And while parsing them, we'll parse the cross-version extensions. So this is the kind of ideas that we know now come into the realm of possibility. Yeah. Yeah, we're in coffee break time. And stroopwafels, yeah, let's hope they're ready. They were fixing them. So let's take a look at the stroopwafels downstairs, guys.